Hello everyone. We're looking at the Unit 6 review of tangent line and writing equations. Okay? And so hopefully when we return, right, when you guys have your unit quest on this stuff, you can utilize this and your study guide in order to answer those questions. Okay? And so in the first one it says, what is an equation of a circle? What is an equation of circle O? Boy. Is that just bad English or what? What is the equation of circle O shown in the graph below? Okay. What is an equation? Whatever. All right, so let's put this together. Now, remember the equation of a circle looks something like this. Okay, where x1 and y1 is your center point. And your radius, or your r, is your radius, right? Your radius is your radius. R is your radius, okay? So, that being said, they give us the center of the point right here. Or the center of the circle, right? The center of our circle is -1, 3. And so the only thing we have to figure out is what is our radius, right? So we can do that by simply just counting north, south, east and west. So 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, and 5. So it looks like our radius is 5. So what we have to do is we have to plug all this stuff back into that equation. Okay? And so what does that look like? Let's zoom out here. So it's going to be x. Now it's going to be minus a -1, so it'll end up being a +1 plus y minus 3 squared is equal to the radius squared, which would be 5 squared. And 5 squared is 25. Okay? So that is the equation of the circle shown, in this case, above, right? So, next part it says, write the equation of the tangent line to circle O, or write the equation of the line tangent to circle O and passing through the point -5, 6. Dash, dash. Point slope or slope intercept are both accepted. Okay? So, let's remind ourselves what those forms are, right? This is y minus y1 is equal to m x minus x1, where x1, y1 is our point that we're going through, and m is the slope, okay? And then this guy here is y is equal to mx plus b, where again m is the slope, and b is your y intercept, okay? Okay. So anyway, those are the two equations that you could utilize. But we have our point, right? We have the point we're going to be going through, which in this case is -5, 6. So the only part we're really missing is the slope that we need, right? And so before we can figure that out, we got to figure out the slope of this radius here from -1, 3 all the way to that point there. Okay? So what is the slope of this guy? Drawing our circle here. So here's our line segment, okay? And we want to find the slope of this guy. Now there's a couple ways we could go about this, okay? Notice that it creates a right triangle here, right? Okay? And then this would give us, well, this distance would be 3, this distance will be 4. So our slope is definitely going to be negative, right? Because it's going down. And in fact, if we go up 3, back 4, right? Our slope then for this guy is going to be, well, down 3 over 4. Okay, so that is the slope of the radius, or slope of the, line segment from our center point to negative 5, 6. Okay? So that's the slope of that line segment right there. So what we're going to need then is our new slope for the line that's going to be tangent to that radius. Come up with a different color here. Okay. So for a line to be tangent, it means that it touches the circle at exactly 1 point. And so that 1 point that we're in reference to is negative 5, 6. Okay. And that also, okay, creates a 90-degree angle. Whoops. With that radius. Okay. So that's why when we're thinking of the new slope, right, this line segment, this tangent line, okay, our slope that we're going to have to use, that's going to be perpendicular to our radius, oops, it's going to have to be a positive 4/3. Okay, so that's going to be our new slope. That's going to be the slope of this line segment that is tangent to our circle passing through that point. And again, to be tangent means that it is touching our circle at exactly 1 point, and that point is negative 5, 6. Okay, so that point that we're going to use is negative 5, 6. Now, we have all the information we need. Now we just need to put it into either form, right? So if we wanted slope-intercept form, we would still have to use the point-slope formula. Okay, so that means this is going to be y minus and negative 5, oops, hey-oh, y minus 6, sorry, is equal to 4/3 x plus 5. Okay, so if we're to simplify this, y minus 6 is equal to 4/3 x plus 20 over 3. Add 6 to both sides, and so y is equal to 4/3 x plus, and because I'm feeling lazy, let's see, 20 divided by 3 plus 6, math frac, would be 38 over 3, which means our y-intercept is going to be 0, 12.6, right? Which is, if you look up there, it looks about where that line would cross. Okay, so I'm happy with that. So either equation would be sufficient. Okay, but again, what we just found is the equation of the line that is tangent to that circle, which means it passes through, or it touches the circle at exactly 1 point. In this case is negative 5, 6. And then that line segment that we just found, that equation down here, okay, is going to be perpendicular to our radius, right? Which means that our radius, the line segment, or the slope of that line segment, which is our radius, that red line, and the blue line are going to have negative reciprocals for slopes. Okay? So anyway, let's go down to the next one. Okay, so it says which equation represents the circle shown in the accompanying graph. Okay, so same type of problem. Here's our equation of a circle. All right, and so our center point is 1, negative 2, and our radius is going to be 3. So all we have to do is plug all that stuff in. Do it in a different colored purple. It's going to be x minus 1 squared plus y plus 2 squared is equal to 9. And that is the equation of that circle. And then it says, which equation of the line tangent to the circle passes through 4, negative 2? Okay, so what we're looking for is the slope of the line that passes through that point and touches our circle exactly once. Okay, so not my, see if I can do that again. Dang it, got the same line. Keeps going back over there. Okay, whatever. All right, so let's just pretend it is touching at that point. Okay, there we go. So this line is tangent to the circle, meaning that it is touching the circle at exactly one point, and means it's also going to be perpendicular to that line segment right there, that radius. Okay, means we're creating a 90-degree angle between that line and that line segment and the radius. Okay. So anyway, what was I saying? Oh, so we need to find the equation of that line. Now, let's take a look at this line segment here, okay? This is an example of a Hoy problem, right? It should be a little more vertical. Let's see if I can make that a little better here, or horizontal, I mean. There we go, okay? So, because it's a horizontal line, the equation of that line has to be y is equal to a -2, right? No matter what value, as if we were to continue this line segment out, right? No matter what value x is, our y value would always be -2. And so to create a line that's going to be tangent to that line segment, it would have to be a Vux problem, and it would have to be x is equal to a +4. Okay, so write the equation of a line tangent to the circle passing through that point. There it is, right? And again, these two lines are perpendicular, right? They have negative reciprocals for slopes. Remember, Hoy, Vux are always perpendicular to one another. Okay, one's horizontal, one's vertical. All right? And so anyway, that's what your unit quest, when you guys return, will look something very similar to this. Okay? So anyway, hopefully this helps. I guess I'll do the... we'll save this problem for tomorrow. I was going to do a video of this, but we'll save that for tomorrow in class. Okay? So hopefully this helps if you're watching it, and good luck.